Okay, this is 5.1 day 1, or 5.5 day 1, excuse me. Notice that you will have 2 days to work on this assignment, and basically one day will be the lesson, the next day will be a work day. It's 2 through 62 every other even, not all the evens. The first example is this one here. The first thing you want to do is get all the terms that aren't just a number value on the left-hand side of the equation. So we want to move this one over by subtracting it on both sides. So we get 5 sine of x minus 3 sine of x equals the square root of 3. Now, if you take 5 sine x minus 3 sine x, you get 2 sine x. And then we're going to isolate the sine of x term by dividing both sides by 2. And when we do that, the 2's cancel on the left, and on the right, as you can see, we get root 3 over 2, positive. Now, basically what we're going to try to figure out is what x is. X is some sort of angle. Now, we're only going to, we have actually infinitely many angles as we rotate around and around and around in a circle that would actually give us this answer. Many, infinitely many. But in this case, they only want us to give them answers in the first rotation, starting at 0 and going all the way around to 1 full circle. So it turns out there are actually 2 answers that give you a positive value of square root of 3 over 2 for sine. Okay, remember, sine is like your y value. And since it's positive, think about what quadrants you'd be in if y were positive. Well, the way I answer that question is, well, y is positive when you're above the y-axis, so we'd be positive in quadrant 1 over here, or above the x-axis, excuse me. So in quadrant 1, y would be positive, and also in quadrant 2, y would be positive. So the side that we're talking about here is the vertical side of these triangles. So square root of 3 over 2 would have to be here and here in order for the sine value to be that. So our question basically is, what are these angles here? Well, for this to be the square root of 3 over 2, this would have to be 60 degrees, or in radians, pi over 3. Okay, so the first answer would start off by saying, okay, we think that pi over 3, x equals pi over 3 is one position. The other position actually starts here and goes all the way over to here. But since the distance away from the x-axis is also pi over 3, how far did we go? Well, 1 pi over 3, 2 pi over 3, 3 pi over 3. So this position right here is actually 2 pi over 3 as a rotational angle. So the other answer is 2 pi over 3. Okay. Now, basically what we have is 2 positions that we have answers for. So it's like we have 2 different type of answers. One at this position and one at this position. So in order to say, well, anytime you rotate around and you stop here, so here's the first answer is pi over 3. If you rotate and keep going and you stop again right there, you have the same answer. Sine is square root of 3 over 2. Or you rotate around again, you get the same answer. Rotate around again, you get the same answer. You get the same distance from the x-axis and the same sine value. Basically, in order to get this answer infinitely many times by infinitely many rotations, you would simply add 2 pi n being the number of rotations past the first one. Same thing over here. If we want to say that we have, this is our first answer, and then we have another one at another rotation, another one at another rotation, another one at another rotation. So basically this position you hit infinitely many times as you spin and spin and spin and spin around a circle. So in order to indicate that all those positions, when they're at exactly that spot, are another answer that gives you the square root of 3 over 2 for sine, we simply add 2 pi n. So we're simply adding another circle and stopping there again to get the same position. So these are actually our 2 answers. This position and infinitely many circles, full circles to that stopping point, and this position, as well as infinitely many additional circles to that stopping point. So I have 2 answers. that look like that. Okay.